Let's start off by talking about ways we already know to solve quadratics. And then let's also talk about the times to solve quadratics with that way. Okay? So what's one way that you know how to solve quadratics? Okay, let's start with graphing because we can remember the name of that. Graphing. Okay? How do we know when to solve by graphing? The number one way is what? If it says solve by graphing, right? We're going to just know that that's understood on every single one of these. Everybody okay with that? But we're going to solve it by graphing if it crosses the x-axis at what? Yeah, at integers. Right? 4, -1. When we can see it on the table, we can prove it on the table, we can see it with our eyes on the graph and prove it on the table, right? So we graph it. Does it cross at x integers? Or sorry, does it cross the x-axis integers? We can go ahead and say that that's our answer, right? Okay? What's another way that you know to solve quadratics? Anybody? How about square roots? How do we know when to solve with square roots? Nope. Good guess, though. If something is squared. Now, I think that seems a little obvious, right? Because these are quadratic, so they're all squared, right? But what do we mean by if something is squared? If we have just x squared, or if we have x plus 2 squared, or if we have x minus 1 squared, right? If something is squared, that we can isolate it, and there's not an x term. Now, I know that there's an x term in here, because things are being squared, but you know what I'm talking about, right? There's not an x term. If it's just something that's squared, we can take the square root of it and go from there, right? I also heard this. How do we know when to factor? Again, that sounds a little rude. I don't mean it that way. We can factor it when it's something that can be factored. If we try to factor it and it doesn't factor, don't try to factor it. Right? Now, what about the leading coefficient? We'd prefer that it was 1, but it doesn't have to be, right? Okay? So what's the last way you know to solve by quadratics so far? We did it yesterday. Oh, completing square. How are we going to know when to solve by completing the square? Now, we talked kind of about it a minute ago. Factoring, we said we'd prefer the leading coefficient to be 1. We could still factor it, though. But what about completing the square? We really want the leading coefficient to be 1. We don't even want to really try if the leading coefficient is not 1. So we want the leading coefficient to be 1. Okay? Guess what I'm going to teach you today? Number 5. Quadratic formula. Now, the quadratic formula works every time. Every single time. Okay? Now, here's the deal. When we talk about formulas, how many times do I make you memorize the formulas? Not very often, right? Because we're going to use them so often that we're going to get used to them, or I'm going to write it on the board for you, or we're going to notice the pattern real quickly, and we'll know the pattern more than we know the formula. This formula, you have to know. You have to. Here's the formula. Write it down, please. Here's how you're going to remember it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Join me! X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I think some of you are confused by what I meant by join me. Okay? I'm not starting a cult or anything like that. I just wanted you to sing the song with me. So let's try it one more time so we're all getting a chance to sing. Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But here's the deal. It doesn't do any good to know a really cool math song if you don't know what it does. What does this do? Yeah, how does it start off? X equals. What are we doing? We are solving for x. We are solving a quadratic equation. That's what this is for. Okay? So what good does this formula do? Tell me. It helps you find x. You're solving a quadratic equation. That's what we do with the quadratic formula. Okay? So can I give you some examples? Okay. We'll start here. What do we have to know in order to solve with the quadratic formula? What do we have to know? Guys, how does the quadratic formula go? X equals negative b, so I got to know what b is, plus or minus the square root of b squared, so I got to know what b is, minus 4a, so I got to know what a is, c, so I got to know what c is, all over 2a, so I got to know what a is, right? Where's a and b and c? A is with the x squared, b is with the x, c is, but they're way easier to see if what's true. If it's in the right order, right? So let's get it in the right order, because what does it need to equal? 0. Yeah, and each equals 0. Okay. So is it okay if, do you want to add 3x to both sides, or do you want to subtract 2x squared and add 4? Does it matter? No, we'll still get the same answer. Okay, no matter which side we move it to. But I agree, we should add 3x to both sides. When we add 3x to both sides, we get 0 equals 2x squared plus 3x minus 4. Everybody okay with that? Okay. If we get 2x squared plus 3x minus 4, that helps us see a, b, and c a whole lot easier, doesn't it? Here's a in front of the x squared. Here's b in front of the x. And here's c, the constant by itself. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah? That wasn't me doing anything fancy. That was just me just substituting in values into the formula, right? Now I just have to solve it. Negative 3 plus or minus the square root of. Guys, here's a question I get all the time, and I want to try to answer it for you right now on the very first day of solving this. Is this a minus 4 or is this a negative 4? Isn't it both? You have to make a decision of what you want it to be. If you're going to say it's a minus, then ignore it and do 4 times 2 times negative 4. What's 4 times 2? Times negative 4? Negative 32. Because then we'll get 9 minus a negative 32, which would be 9 plus 32, right? If I did 9 and pretend that was a negative 4, I'd have to write 9 plus negative 4 times 2 times negative 4, which would be positive 32, and it would be 9 plus 32. I'm going to get the same thing either way, but what you can't do is write down 9 minus and then treat like this like a negative 4. See what I'm saying? Do you see why people might get confused? But that's not you. You're not going to do that, right? Okay, good. Negative 3 plus or minus square root of what? Oh, 41 over 4. Do you know the square root of 41? Yeah, me neither. Do you know anything that multiplies into 41 that you do know the square root of? Okay, me neither. Is there a common factor here, here, and here that I could factor out? No. So guess what this is? The answer. The end product. Got it? Okay. What about this one? 3x squared plus 6x plus 3. Ooh, it's nice and all in order and everything for us, right? So here's A, here's B, here's C. Guys, just for the record, can you tell that I'm trying to be really careful what I underline? I don't just go all the way over here to say what A is, right? A is only the term in front of the x squared, doesn't include the x squared, right? Okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now what? $36 minus, what's 4 times 3? Times 3? Okay. All over 6. Anybody know what 36 minus 36 is? Oh, 0. What's the square root of 0? So if I plus or minus 0, does that even make any difference? So I just get this, right? What does x equal in this problem? -1. Now, some people don't like this because they remember the fundamental theorem of algebra says I should have two answers, right? I only got one. Did I do something wrong? No. What you need to remember and what they need to remember, not you because you wouldn't do this. If that's -1, there's my graph, right? How many times does it touch the axis? Once. What's this called? A double root, right? So how many times does -1 actually happen? Twice. Do we write it twice? No, we don't. We just write it once because it only touches the x-axis once. But remember, this is a possibility and this is okay. Okay? What does this graph look like? How many times is it going to cross the axis? Twice, right? Wherever -3 plus the square root of 41 over 4 is, and wherever -3 minus the square root of 41 over 4 is. So this is not an exact replica of the graph, but something like this, right? The fact that it's crossing the x-axis twice. It's just not at nice, pretty integers like we'd like. Everybody okay with that? Okay. And you're good with this one, right? Okay, then let's talk about this one. 2x squared plus 4x equals 30. What do I need to do first? Subtract 30 from both sides because I got to get it equal to 0, right? So 2x squared plus 4x minus 30 equals 0. What do you want to do now? A, B, and C? A, B, C. Don't tell me what to do. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. -4 plus or minus the square root of. Can I pause for a moment and make sure that you've seen what I've done for this example and for the last two examples? Because I do it on purpose. Maybe I should wait until the next example when it really comes into play. Yeah, I think I'll do that. I want you to realize that I've done something on purpose, especially right here, that I want you to notice, and we're going to do it on the next example because the next example is when it really makes a difference. Okay? So I have 16 minus, what's 4 times 2? 8 times -30. 8 times -30. 8 times -30. -240. Right? 240. It's just the arithmetic. 4 times 2 is 8. 8 times 30 is 240. And it's a -30, so it's -240. We good? Okay. Over 4. X equals -4 plus or minus the square root of what? Do you know the square root of 256? I do. Use your calculator. Yep, everybody should be getting their calculator out. Square root of 256. $16. This is a little different, isn't it? Negative 4 plus or minus 16 over 4. Do I stop here? No, I can definitely keep going, can't I? What is negative 4 plus 16? 12 divided by 4? 3. What is negative 4 minus 16? Negative 20. Negative 20 divided by 4? Negative 5. What does this graph look like? Something much prettier than that, but you get the idea, right? Crosses at 3, crosses at negative 5. Any questions so far? Okay. What to do first? You want to move these two onto this side, or do you want to move this one over here? Okay. So if I subtract 4x from both sides, because I really want it to equal what? 0. 5x squared minus 4x plus 6 equals 0. What's A? 5 is A. What's B? B is negative 4. And what's C? Look, I wrote 6 under 6 instead of writing C. So weird. X equals, uh-oh. Yes, it does. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So do you see what happened here, first of all? X equals negative B. The negative is in the formula, so it's a negative 4. It's just a 4, right? Okay. So x equals 4 plus or minus the square root. This is where I want to stop for just a second and make sure you've seen what I've done on every single one of these problems that we've done so far. What's the very first thing underneath the root sign? X equals negative b plus or minus the square root of b squared, right? How many times did I literally write b squared? I never did I? I know that 3 squared is 9. I know that 6 squared is 36. I know that 4 squared is 16. Well, none of those would have been a problem if I would have written 3 squared and 6 squared and 4 squared. This is where it would be a problem if I wasn't paying attention. Because guys, if I write negative 4 squared in the calculator, what is it going to tell me? Is that what I wanted? No, it's not. But the calculator does an order of operations. It squares and then multiplies. I know what negative 4 squared is, so I just went ahead and wrote 16. I could have written negative 4 squared if I wanted to, because that's what I actually need to do if I'm going to write it down, don't I? But I just always go ahead and square it in my head. Or with my head. Sometimes I have to use my calculator if it's a bigger number and I don't know it. All right, if b is 27, I don't know what 27 squared is. Okay? But I'm going to just square it. I'm going to write it down, aren't I? Do you see why I do that? Okay. So 16 minus, what's 4 times 5? You guys are terrifying me today. 4 times 5 is 20. 20 times 6? 120. Okay? All over 10. Four plus or minus the square root of what? Negative 104 over 10. I really wish we would have spent some time lately taking square roots of negative numbers. Oh yeah, we did, didn't we? Come over here. How do we take the square root of 104? I break it into its parts, right? What are its parts? Negative 1. For sure, negative 1 and 104, right? But do you know the square root of 104? I don't. But do I know something that divides into 104 that I do know the square root of? So I agree with you that 2 divides into 104. But do I know the square root of 2? I don't. Yeah, what about 4? Doesn't 4 divide into 104? 4 and 26, right? Can I break 26 down even further? It's 2 and 13. I don't know the square root of either one of those, do I? So that's as far as I can go, right? What's the square root of negative 1? I. Good. What's the square root of 4? 2. What's the square root of 26? I don't know either. Now, why didn't I worry about the plus or minus right here? Yeah, it's built into the equation, isn't it? Built into the formula. 4 plus or minus 2I root 26 over 10. Notice, please, in the numerator, there's a common factor. What is it? 2. If I factor a 2 out of every term, what do I end up with? Yes? Guys, why didn't I factor a 2 out of the 26? It is in the square root. The only time I can take something out of the square root is if I know the square root of it. It doesn't matter if it's divisible by 2, just like everything else is. I can't take it out unless I know the square root of it. Does everybody understand that? What can I do with the 2 and the 10? Don't those simplify now? This is a 1 and this is a 5. So what is my final answer for this problem? Yes. 2 plus or minus I root 26 over 5. That is as far as I can go. That is my answer. Can you tell me what the graph looks like? There's 2 solutions. What kind of solutions are they? Imaginary, which means I don't know exactly where it is, but it's going to look something like this, isn't it? It does not cross the x-axis, does it? Okay, got it? Any questions? Those are the examples I have for you today. Think you can handle those? Quadratic formula. Do you know it? Prove it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Perfect. I know soon we're going to be able to start a band, right?